Hey Math 1B, got a new video for you from Chapter 4. This is all about polynomial multiplication. So the last two lessons, first one was about classifying things, second one was about can you add or subtract polynomials, bringing the like terms together. This one's going to talk about how to multiply. So hopefully you guys will catch on to this quick. No problem. So when you see a term on the outside of parentheses, there's implied multiplication happening there. Okay? So you're going to try to take 3ab squared times b squared. Okay, that's going to be your first calculation. Your second calculation is going to be 3ab squared times negative 12ab. And then your third calculation is going to be 3ab squared times 4. So all I'm doing is employing the distributive property, which means something on the outside multiplied by multiple things inside. Take it, times everything. Now in the last video, I said you could not combine unlike terms. These are technically unlike terms, but when I said combine, I meant add or subtract. You can actually multiply unlike terms. Here's why. B squared times b squared. If you ignore the 3a, b squared times b squared is going to be b to the fourth power. We've got rules for that. Multiplying powers of same bases, you add the exponents. Now multiplying something just means to put it in front. So that's 3a times b to the fourth power. And that's perfectly legit. That's our first term. 3ab squared times b squared is going to be 3ab to the fourth power. Check it out here. I've got 3ab squared times negative 12ab. I'm going to put it over here so I got more room. You can actually use the commutative property to rearrange some things. Okay, so 3ab squared is 3 times a times b squared. Negative 12 times a times b. The commutative property says I can rearrange it in such a way that the 3 and the negative 12 are side by side. The a and the a are side by side. The b squared and the b are side by side. You guys learned that from the very beginning of this chapter when we were multiplying, or no, it was last chapter. Last chapter we talked about how rearranging things using the commutative property allowed us to simplify the like term. So this is just going to be negative 36. A times a is a squared. B to the 2 times b to the 1 is b to the 3. That is my second term. So 3ab squared times negative 12ab is minus 36a squared b cubed. All right, so I think you guys are seeing how this is going to pan out. We got rid of that one. We got rid of that one. Now it's just a matter of multiplying the 3 times the 4, and it's going to be a positive 12ab squared when I take 3ab squared times 4. All right. There's my answer. I'm not going to be too concerned with standard form on this assignment, so, don't really pay attention to this part. Just tell me what the degree is. In this case, it's 5. And then the leading coefficient, it's 3. I guess I want you to be able to do this more than I want you to be able to do this on the assignment tonight. So there's number 1. Let's check out number 2. So number 2, I'm taking a squared times every separate term in this first group of parentheses. In the second one, I'm taking a positive 3a times everybody. So if you think about it, I don't know if I need to rewrite everything and show the rearranging. What I'm going to do is just kind of do it in my head. A squared times a squared is going to be a to the fourth power. And think of it as a 1 in front as its coefficient. So you're taking 1 times negative 8. Second term, 1 times 2 is a positive 2. A squared times a to the 1 is going to be a to the 3. And then 1a squared times 4 is going to be a positive 4a squared. Okay? That's what happens when you distribute the a squared to the first group. When you distribute the 3a to the second group, you're going to get 3 times 6, which is a positive 18. A to the 1 times a to the 3 is going to be a to the 4. And then 3a times negative 4a is going to be a minus 12 AA. So it's a squared. Now, don't stop there. If you'll notice, I have an a to the 4th term here and an a to the 4th term here. Those two should be combined with one another. Now, here's where things get a little tricky. You have to really, in your brain, separate the rules. When you multiply, you can change the exponent. When you add or subtract, negative 8 plus 18 is a positive 10. You keep these the same. Right? You're just dealing with the coefficients, and then the a to the 4th is a tag along. Okay, so when I add or subtract, it's still going to be a to the 4th for my term. There's no partner for 2a cubed, so I'm just going to write it down here. But the a squareds can be combined. Positive 4 minus 12 is going to be negative 8. And it's going to be a squared. So there's your final answer in standard form. The degree is going to be, let's see, between 4, 3, and 2, it's going to be a degree of 4. The leading coefficient is positive 10. Oh boy. So number 3 is just kind of like a, I don't know how you put it, just kind of like a challenge problem, a beast treat, if you so choose. I don't know if I need to do this on the video. I'm going to skip it for now. We might come back to it. I just want to see how much time we have after we do the last couple. All right, so what happens when I put an equal sign between two expressions? Well, the first thing I want to do to solve this equation is get rid of parentheses. If I can get rid of parentheses and add or subtract to combine like terms, that's my first goal. So I see a 4 on the outside, take 4 times every part on the inside. So this is going to be 4x squared minus 28x plus 56, since 4 times 14 is 56. All right. On the other side of the pond, you got 2x times x, 2x times 3. 2 times x squared, 2 times negative 13x, 2 times 8. If you compute that, you're going to get 2x squared plus 6x for my first group. For my second group, I'm going to get 2x squared minus 26x plus 16. So these two from here, these 3 from there. Okay, so now what I'm going to do is I'm going to simplify the right-hand side as best I can. The left-hand side seems like it's pretty simple. Nothing much to be done there. So I got these two. That's 4x squared. These two. 6 minus 26 is minus 20. And then 6 is just kind of a tag along at the end. All right, so here's the idea. If I can move like terms from the right-hand side to the left-hand side, let's do it, okay? So the 4x squared, to move it to the other side, I'm going to subtract it. And luckily, it completely cancels them out. Now, I I can get the x terms together too. I'm actually going to add 28x here. All right, so that gives me 56 on the left equals negative 20 plus 28. That's going to be 8x plus 6. All right, and then it turns into a relatively simple equation to solve. How do I get x by itself? Take away the 6, you get 50 is equal to 8x. Divide both sides by 8. And if you simplify this, it ends up being, you can cut them both in half, 25 over 4, which is the same as 6 1/4. Oh, mercy. Why do I have so many examples? You know, we might not have to do all these notes. Let's just see. Try number 5 on your own. See if you can make sense of it. Pause the video, try 5 on your own. All right, let's check and see if you're correct. Take 4 times 5x, 4 times 6. You get 20x plus 24. Oh, take negative 2 times x, you get negative 2x. Negative 2 times negative 4, make sure that's a positive 8. Big mistake alert is to make that negative. It's positive. On the right-hand side, you've got 7x times x, which is 7x squared. 7x times 4, it's positive 28x. Negative x times 7x squared is minus 7x squared. Negative x times negative 2, positive 2x. And then you just got a minus 42 hanging out. All right, so check it over. Now simplify what you can on the left-hand side of the equation. I got a 20x and a negative 2x. 18x. Over here, I got 24 plus 8. That's 32. On the right-hand side, I've got 7x squared minus 7x squared. That's 0x squared. They cancel out. 28x plus 2x is 30x. And then you got a minus 42 still floating around. So I'm going to move this 42 to the right. Notice I'm using the opposite sign. And I think I'm going to move this 18x to the right. Opposite sign of plus cancels it out. So 42 plus 32 is 74. 30 minus 18 is 12. You can divide both sides now by 12. If I cut the top in half and the bottom by half, that gives me 37 over 6, which is the same as 6 1/6. All right, you know what? I think we got time for one more, so I'm just going to do number 6. And then on the notes, the top one, just you can leave that be. Again, I would encourage you guys to pause the video and try this on your own. Do a quick self-check to see if you know what you're doing. All right, let's check for understanding here. Take 4y times negative 6y. Negative 24 double y. Y squared. 4y times negative 12 is going to be a negative 48y. Now take a positive 24 times everybody inside this group. Negative 48y. On the other side, you got 3y times 3y, 3y times negative 8. That's 9y squared By the way, notice I put an equal sign here. Don't forget to put that equal sign where it should be. It's separating the negative 24 and the 9y squared. So that's going to be minus 24y. And then you got negative 9y squared. And then a negative 9 times positive 4y gives you negative 36. With a y at the end. So you guys gotta have some endurance to work your way through some of these problems. It takes some mental effort. All right. So combine like terms on the left. Looks like we've got a negative 24y squared and a positive 24y squared. 0y squared. That's always good news, yeah? Then we've got negative 48y minus 48y, okay? They do not cancel each other out. You get negative 96y. Hopefully you guys can see that. I believe you can. And then the negative 24 is still just hanging. On the other side, you got your y squareds. Plus 9, minus 9, cancel, cancel. And then these two actually do combine. It's going to be a negative 60y. All right, we got to finish this up soon because we're pushing 16 and a half minutes as it is already. I'm going to move this negative 96y to the other side. That gives me negative 24 is equal to, opposites subtract, so it's going to be 36y. And then just divide by the number in front of y. All right, this reduces to negative 2/3. Okay, so thanks for sticking around for the 17 minutes. I do appreciate it. Thanks for watching, and make sure you fill out the notes and attach those, and also attach the homework. Thanks, guys.